I was curious about like what kind of the political geography of Orange County looks like. And just kind of starting with the punchline here from the get-go. This is what the election result for 2020 looked like for Orange County for the presidential election. I'm gonna, in this talk, go over like where I got the original data, some of the tools that I had to use to get it into a format along the way to kind of get to this visualization. It was a decent amount of work, but I think just kind of for a moment right now, kind of can just be fun to just kind of step back and appreciate that like Orlando is super diverse. Orange County is pretty big. We have, there's a lot of deep blue, there's a lot of deep red, there's a lot of kind of purple and light shades here. And yeah, making this was quite an adventure. So I'm just kind of like go over like briefly kind of just like what the end result was. So like I want to like start kind of with these images because I think it's kind of fun to just kind of frame like it's kind of like with I guess I'm kind of digressing here, but like with the Odyssey, I don't know if anyone's here ever read like Homer, like the Iliad or the Odyssey, but like they start at the end almost to kind of give you an idea of where you're eventually going, and then like start all the way at the beginning. So that's kind of the approach that I'm taking right now. I also have the 2016 results, which were a little different. So I was able to kind of see like how the vote across Orange County shifted. This is kind of how the precincts shifted from one election to the next. So for all the talk in the news of kind of how different there were kind of demographic shifts in the electorate, like white educated voters shifting Democratic, Latinos, and to a smaller extent, Black Americans like shifting slightly toward the Republican column. For the most part, like how precincts at least at the precinct level, results didn't really change that much from year to year, which is kind of the norm in American politics. For all the talk that we talk about these kind of changes at the margin, by and large, I mean, I don't know exactly what the correlation was from 2016 to 2020, but I guess it was probably like 0.95 judging visually from this, or maybe like lower 0.9s. And then I was also able to look at kind of at the geographical level, how much did things change toward one party toward another. So what this shows is the margin shift. So like with the original thing that I started was just kind of like the raw absolute level of support, whereas this is how much things changed from 2016 to 2020 by geography. So like if we kind of zoom in here, and by the way, I'm going to, in Jupyter and in Python with Plotly and the libraries that I use to make this, we can like zoom in and see a little higher quality. But, zoom out a little bit. In general, kind of in these northern parts of like North Orlando, like north of Highway 50 or the 408, things became a little bluer. In Azalea Park and down near the airport, and also over toward Metro West, things became decently more Republican, maybe about with margin shifts between 10 and 25 points. Out here in near like Windermere is, I think this was kind of interesting to look at, like where were there kind of bluer shifts? Windermere, if I go back to like the absolute support, we can see how Windermere is a pretty red area, and it was even redder in 2016. So just to kind of back up again to this, like some of the broad themes happening here, places that were really blue trended a little bit red, and places that were really red trended a little less red. So there's kind of this like depolarization happening. And we can kind of we can see that here, where like places that are more red are where like showed like a little bit of blue shift and vice versa. And we can also see that in this this here, where like literally the slope of this is like if places here that like that are like much more democratic or like were a little bit less this time, and then places on the more Republican end of things were a little more like at least like less Republican than usual, or as compared to what they used to be. So maybe I'll just like pause right now because I've kind of like gone over like a lot of politics, I guess, and just kind of like I wonder like what's on people's minds. Like, is this something that you've kind of heard about? Is this like new to you? Is this interesting? So I don't know. Unmute yourselves if you'd like to.
Well, it's always nice to have context around the data, and especially in this, starting with this, you're seeing what we're going to work to for the remainder of the talk, which is also good.
Yeah. Yeah, so, okay, so I'll just kind of go into that. So let's say I'm going to come out of this and yeah, so what I have here, this is kind of a agenda that I'm going to go through. So first I got precinct. So kind of to start actually like where I first initially started was with 2020 results. So if you go to the Orange County of Elections website, if we're like actually at the homepage, you can like click and like they have all the official results here. And then they have this really huge PDF file that's like 633 pages long, literally with all of the election results, not just the presidency, but also like whether all these individual judges should be retained, whether we should have a minimum wage of $15 an hour, etc. I did not get into those other down ballot things that would be interesting to look at. But the way that, so I'll kind of like first go into like how I got this into, how I got this data. But like in general, the what I'm going to be using is pandas, which sorry, I'm like talking more than I usually do now right now. Like raise your hand if you're familiar with, like on the camera, raise your hand, I guess, if you're familiar with pandas and like use pandas. Okay, yeah, so like basically everybody, at least in like the Python world. Wes, it's okay if you don't use pandas. Cool, great. It's kind of like Excel, but like you can do a lot of useful stuff with it beyond just like, you know, VLOOKUP and like doing like little plots and pivot tables. There are for example, like with Excel, there are pivot tables where you can like, you just do like everything in Excel and more. It's very flexible. So kind of like what I did here was like there was this big PDF file. This is all tabular data, and then I found this. I found this library that can just like read in a PDF. If it has a bunch of structured tables, it'll just return a data frame for each individual page, parsing the table in it. Or I think it just maybe looks for each table and it just like creates a data frame for it. And you can like specify the page range. So I'm not going to go into this very much. It's pretty straightforward. I just, you know, got all the data in here. As you can see, it's just in like a huge data frame. But like maybe it's useful to kind of point out like you can like concatenate data frames. They're all the same format, so they all can just like all the individual pages I could just smash into one. And then also with the 2016 data, let's see, where did I get the 2016 data in? I had that just a moment ago. I think actually maybe it is here. So with the 2016 data, right, so I found the way that I came across this 2016 data was like, okay, great. I have the 2020 results by precinct, but if I want to make a map of this, I need to actually have some sort of like geospatial representation of the precincts to like join in. Like that's something that like I knew that I was going to need. Like I've done a little bit of geospatial work before, and the what you kind of look for is something called a shapefile. And if you're not familiar with shapefiles, it's okay. Like I didn't know what a shapefile was prior to like a couple of years ago. What they are is like a data format for shapes in like on a map. So like counties in the United States or even like states, like any sort of either point or some sort of blob that you could somehow define could be like defined in a shapefile. And so like there are a lot of people out there on the internet who are like into election analysis. So I found some, I forget exactly what the link was. It's not really important, but like a GitHub repo that had like all of Florida's 2016 results in a shapefile actually. So that was like surprisingly easy. Someone had already done this work, and the way to so then like the next question was, okay, now that I have these shapefiles, which by the way, I can show you kind of like what it looks like. Where is it? Oh wait, this is full screen. Here we go. It's like the way these shapefiles work. They're always in this kind of directory structure. I'm just showing this to you in case you ever like come across this problem in the future where you're working on a geospatial problem. They're always like this big collection of files. I don't know like exactly how all the files are different, but what you do is like there's always this one really special file that's like .shape, and what you do is like you can use there's this library called Geopandas, which, as you can probably guess by the name, is just kind of like a modified kind of extension of pandas, where you can like load in a shapefile, and it'll like create a data frame where each row is has a bunch of like shape information. Like if you have like a certain number of shapes that your shapefile has, it'll just like give it to you in this nice data frame format. Then you can like combine with other data, which is what we're going to do. And so this thing was like every precinct in the state. So I didn't like show what like all of this looked like, but if we look what's in here, there's like Dade County down to I don't know what HOL would be, but yeah, and it's like 6,000 rows. So there's like 6,000 precincts in Florida, basically. And like I just got orange. And then, so as I was researching how to visualize this data from Geopandas, I was like, okay, great. Like I have geospatial data, like the shapes, and I also have some attributes. Then my quest was, since I had all the data and data frames, which maybe took like 6 hours from trying to figure out like how I can parse the data and find it, was how can I visualize it? So like 90% of the work when all this was like figuring out how to actually visualize everything. So actually Geopandas does have kind of like a nice built-in way to make like an okay visualization. So that's what this is here, where you can just like from the shapefile directly plot, and it'll like create this thing, which it's pretty good. And actually I wonder, I think we can also actually show like all of Florida. If I do this will probably work, because what I had in here originally was only Orange County. Yeah. I actually have never seen this before, but this is like how many votes Clinton got in 2016 in every precinct in Florida. So it looks purple. Like so what this is, it's like the absolute number of votes. This isn't like a percentage of the vote. It's just an absolute number. So this isn't like, if you're kind of wondering like why everything's roughly the same color, it's just like vote counts. So I got all of this data in here. From this point, so like at this point, I have like a way of making like an okay visualization, but what I really wanted to have was something kind of more, I mean, what I kind of came up with at the end here, with this is like what I'm working toward right now, where with Plotly, I can have like a more interesting map. So like I have these roads here and I can like see like where all the precincts are kind of relative to like I-4 and the airport and stuff like that. This provides more contextual information, which is like all missing from this thing. And the libraries that were used to make this were, so far, we're dealing with Geopandas and a related library called Descartes, which I think is like some sort of Cartesian plotting thing that's used for geospatial data. So let's see. Yeah, so then the next step is I need to like combine all this data together. This is just like a lot of pandas munging, which I'm gonna like, maybe the best way to kind of go through, let's see, where does everything happen for that? I think I did a few things in other, I might have done some of these steps in like another notebook, but I think, and also my computer is like really slow with the Zoom, I'm realizing, but that's okay. Oh yeah, so like when I first did, I think like in this notebook, and first just like, okay, I have a bunch of stuff in from Geopandas, and I just wanted to like see if I could visualize it with Plotly's Mapbox thing, and so like that works really nicely. I think this was like the first plot that I made with Plotly's Mapbox thing, and this is like pretty good. So what we have here, like this is like zoomable. So yeah, I've kind of just like jumped into this. So like where we are right now, okay, is like we got all the geospatial data in a data frame, and with Plotly, I'm able to kind of like dump that into this like, I'll go over the interface for kind of how Plotly lets you do this. But if you have a data frame with attributes and shapes, which is what we have, it can make these really nice maps that are called Coroplots. And what a Coroplot is a map where there's like shaded colors and opacity based on some like data that you have. So these they're kind of like a heat map, but for maps. So like a heat map would be like, you know, showing like where there's higher density of something or like more temperature. And this is just showing like where the Democrats are, like where the Republicans are, basically. And so like this, I mean, I guess I could have probably like stopped here and like this would have been wonderful. But there are like a lot of different things you can tune about this. Just kind of back up like how actually like, I'll kind of walk through how you can make this kind of Coroplot map. There are a couple ways to do it. So here I have, let's see, let me just see like, where did I, there are a couple of, let's see. Okay, this is the parsing. Okay, here we go. So, so I just kind of showed the Choropleth map. In this Choropleth map, there is, as you can see, this is like actually showing percentages of party support by geography, by precinct. And so how this is working is I have a data frame that has where I provide. Now there's a few steps here. Okay, so what the Coroplots wants is it wants something that defines shapes. It wants values, and it wants like locations that correspond to those values. Because what you can do is like you could provide it with shapes, but then like just have values like all sorts of random different points. What I'm doing here is I have values for each precinct, and then my shapes are the same, or like also for the precinct. And so I'm just showing all of that together. And so what it calls for is something called GeoJSON. And GeoJSON actually, so when I was talking about shapefiles earlier, shapefiles are probably the more common format for storing something like a geographical unit. You can also, there's another data format that maybe is like a little more web friendly, definitely more web friendly, called GeoJSON. And basically it's like a way of like storing and expressing the same kind of geographical characteristics in a JSON format that is like more ingestible by web APIs. So the Plotly interface, there's like a lot that's kind of going on here. So like we have like the Z values govern like the color on the of like each individual thing. So what I have here is something called like this, there's like a column name. I'm then also creating, I want like, so this is like the Dem fraction, the fraction of votes in this precinct that were Democratic. And so then I have to like make sure that like places that have more Democrats are blue, places that have less are red. So I have to create something called a color scale. There's like also, I can like change how, whether there are borders in this. There are just so many different things you can change. It's really complex. I'm not going to go into everything that you can change with the Coroplots. The main thing that is useful to take away from this is that I think like honestly I would say if you do want to ever like visualize geospatial data, you do have a few options. I would probably say that Plotly is the best one. I've used a couple of different things. ArcGIS is great. So like ArcGIS, kind of just like stepping back for a moment here about like visualizing geospatial data in general. Because like I've chosen this stack, but one thing you might kind of be wondering is like, why did I go with Plotly in the first place? Why am I going down this path? You could also, like if you have, like if say like I gave you this data frame that had these shapes and the precinct data, you could also use another program called ArcGIS, which is like really common that people use for visualizing spatial data. But that program is like really clunky. It's like, it's a GUI, it's not programmatic. If you want to publish something to the web that's interactive, I don't think that's possible. I think maybe there are some, like they do have like a proprietary website, like ArcGIS is this company, or like you can like publish geospatial data on their website. So they kind of have this like proprietary system, but it's like a very closed, not very flexible, a little old, like not very easy to work with. Whereas Plotly, I don't know like how much data visualization experience people have. Like from the experience that I had with Plotly, Plotly just has like a very neat API with intuitive and flexible ways to create visualizations. And like I feel like things that are both intuitive and flexible seems like really rare. Sometimes things can be flexible and like make no sense at all because it's just like Matplotlib is super flexible and makes no sense. Like, and so you kind of get the idea. Plotly just seems really well designed, and So like, for example, just to kind of give an idea of like all the different knobs that you can vary to change how your visualization looks. I just changed the marker line width, which changes like how precincts look. And this looks pretty cool. You know, like I can see actually like, here's like the Windermere precinct. I can see, you know, actually where the boundaries are of things. So there's a lot of different things that you can change. Let's see. I've been talking for about 25 minutes or so. So maybe I'll just kind of pause for a moment. Does anyone just kind of have any like thoughts or kind of questions about things?
Have you thought about overlaying some demographic data on this, like you know, income levels or anything like that?
Yeah, great question. So the census, as you probably know, the American Community Survey has a ton of information at a very specific level, actually lower level than precinct, which we have here. Unfortunately, I do not have that. But that's definitely something that would be, that I was chatting, you know, like texting or slacking, whatever the verb is, with Michael about this earlier, that like that is something that I would like to add in. But yeah, for the purposes of this, I wanted to kind of just like go deeply on like how do I kind of parse, store, and visualize just the precinct results.
Now, what you have is really nice. That was just a suggestion for future research.
Yeah, absolutely. The census has a lot of great data. Yeah, I mean, geospatial data is really interesting. I think there's also a lot of interesting kind of statistical methodologies for and challenges with analyzing geospatial data. So one thing kind of related to this, maybe I'm going to talk a little bit more about Plotly and some other visualizations that I've made. But afterward, I kind of want to just kind of like touch on some thoughts about spatial statistics and some discussions that people have been having online about that with kind of analyzing election results. So thanks for the question. Yeah, I agree. I think that'd be a great idea. I just don't have the data for it. Anyone else? Okay, cool. So from here, what did I want to, so I've gone over kind of, yeah, getting data together, some initial visualizations. So if you ever want to make plots in Plotly with these maps, what you're going to be using probably is something called Mapbox. And so like, you might wonder, let's see if I zoom out a second here. You might wonder like, where does this background come from that has like these lakes and roads and so forth? Because what we can do here, I'm just gonna show. Let's see if I can make this work. We can choose, there we go. We can choose like a different background as well that has different kinds of detail. So let's see, here we go. That has like different colors and like labels for information. You know, we have like more name. So these are called styles. There's like a lot of different options for them as well. Given that my computer is slow, I'm not gonna like demonstrate them for you, but like they're all on, they come from this website called mapbox.com, which what Mapbox is a few things. And Michael, you probably know more about this than I do. But since I'm talking, I guess I'll do my best to describe it. So like Mapbox is this website that they kind of like create web-based maps that you can make maps of, basically. In JavaScript, like there's like a JavaScript library called Mapbox GL that you can like embed in a web application to like show maps. And then you can, if you want to like, they have different like styles of maps as well, where like things called like tile sets, where they have like, for example, like this is like a dark map. My computers are so slow right now. But you can kind of see, here's like Paris with like a dark styled map. They have like a ton of different types of maps. If you want to have like a custom map, you can just like go to Mapbox, and you can like, if you're like, say like if you are familiar with the app All Trails, which is like really good for hiking. It has like various like hiking routes. Like All Trails uses Mapbox. So like if you pull up a trail on All Trails and like look at the map, like they pay Mapbox for like all the data and like a certain nice visualization of maps. So basically Mapbox gives you a nice background. And there are like many ones you can choose. And you can also kind of them. So like I chose to like when I was trying out this style, like this is, you know, a very nice style in that like it gives me a lot of locational like if there's like descriptions of things, like I can see like different neighborhoods and highways. But one thing that I don't really like about this map is that it has so much color. And so like, for example, lakes are blue, but like in my map, I want Democrats to be blue. Like I don't want people to like get confused and be like, whoa, there's like, who are the green people? And like, what is all this like weird turquoise? Like it's very distracting. It's like, it's just too much. Even for those of us who like data visualization, it's a little too much. Like people who are like used to looking at and consuming a lot of info. So what you can do is create like a custom map. So that's actually what I did. I don't know if I want to get into this. This is just this is a little bit of before, where I was like having to like create these columns. Like I had vote counts, and I want to make fractions. I'm like creating these like new columns, basically loading in other data. This, yeah, some like panda stuff. Let's see, where was it? This is Carto. Let's see. Wait, somewhere I had let's see. Oh yeah, okay, I think this is it. Let's see. So what I'm trying to get at here is get to a part of my code where I created a custom map, and then something doesn't have as many of the lakes and stuff like that. So like this is getting kind of deep into Mapbox, but what you can do is let's see, is this still executing? What you can do is you can go on Mapbox's website, and you can actually like, you can take one of their default maps, clone it, and then modify it, and then save it as your own style, which then you can use in like whatever visualization you have. And so like one thing that's nice is like if you want to have like no land and water, you can just like totally delete all the land and water, like, which is what I think I might have done that. So you like just get the roads, or if like you wanted to remove roads, and like vice versa, you can, anything that you want to like add or subtract, you can pretty much, you have full control over that. And this is through something called Mapbox Studio. So there's a lot of control over what kind of additional information with our map we want to have in the in this this Coroplots map in this web application that Mapbox has. You can edit a map, and if we go to like one of the other ones, if this works fast enough, we can go into like the streets one and like change the color for water. Water can be white. So I'm not going to go through all of that, but like Mapbox's website, you can kind of like figure that out. And there's like a few other, you have to like create like an API token. But once you have like all those things, it's good to go. Let me think what else. So I think I'm probably just about through kind of going over how to make the plots. I think maybe we'll just like, for purposes of the for the Plotly stuff, also kind of show how Dash looks. So if we have, let's see, because Michael mentioned Dash, I need to create another plot here to kind of show this. And this is, oh, I think I need to interrupt the kernel maybe. Okay, this should be quick. It's taking a while. Okay, good. So this is going to render. So what we can do is, so what Plotly does, for those aren't familiar with kind of how, like, how Plotly kind of works. So like, as Michael was saying, Plotly kind of is like, at its most native sense, like a JavaScript library. Everything that's happening that's powering this visualization is, I think this might be like a Jupyter widget running in the Jupyter Lab notebook, which is like running its own little like node server powering a website. So like everything's just in JavaScript, and Plotly is literally creating this huge, if my understanding is correct, like a huge JSON object that just has all of the data and attributes that are going to define what the plot looks like. So that's like really nice. It's like all self-contained. If you wanted to like, if I wanted to give you this visualization, I could just like save out a JSON file, send it over to you, and you could like load that up and like look at the figure. And like, so where all this data is in this this fig object. So the figure has data, which has like what the different values are in the precincts and stuff like that. And it also has metadata, I guess, for like how things like the legend and the scaling and stuff like that. What markers look like, or like the precinct lines, like how big they would be, for example. And then what we can do is with that figure object, this is all kind of a snap, because we can just, the way that Dash works, it's a Python library that then runs this little web server for us, where we can kind of like create a little website that just shows our figure, and then we can load up the website, and then hopefully it works. Great. Yeah. And then so like, so this is kind of an example of like something that Plotly lets you do. I could host this somewhere and like share it with someone, and it's all interactive and zoomable and all that. I'll maybe, oh yeah, we can like zoom in and like really kind of see like where the Democrats are. Lots of Democrats down here. Oh, Baldwin Park. So what this is, by the way, is this is the margin in each precinct. So like 0.12 would be like Biden's percentage minus Trump's percentage. So maybe Biden got like 60.8% of the vote here, and like Trump got like 39.2 or something like that. And so like this is just pretty neat. Does anyone want me to like go somewhere in particular where we can like poke around? Any nominations? Anibal, where should we go?
So let's go to Dr. Phillips, which is like to the east of Windermere, like near Universal, let's say.
Dr. Phillips Universal area?
Yeah.
Yes, let's see. Yeah, here we go. It even has a label. This is like, this is one of the reasons why I love this Plotly Mapbox thing, is like it gives us like human descriptions of where things are. But yeah, so down here, this was like really close. It was barely Biden and Dr. Phillips, or like down here is like a little bluer. I guess near the Smiles and Bombs area with Lockheed Martin and Universal. Very democratic, but one thing that would be nice maybe to see here is places that are like really lopsided. Sometimes it's just because it's a small sample size. This is a pretty big precinct, so I'm actually kind of surprised that it's like so democratic. I don't know if Wes has any domain.
Yeah, it's a big precinct, but it's mostly commercial stuff. I believe what's making it so blue is that where's Sand Lake? Right where right where your mouse is now, that's Tangelo Park, which is a very democratic area. That's why it's so blue. That's the main residence in the area right there.
Interesting. Like this here, kind of like this,
Yep.
These streets. Okay.
Yep, that's Tangelo Park, which is a predominantly African American neighborhood. That's why it's mostly democratic.
Oh, okay. Yeah. So this would be, thanks. Yeah, and this is like also why, relatedly, why having some demographic information, at least to kind of like toggle or like overlay, would be nice. But I don't have that. Thank you again, Wes and Anibal, for the suggestion. Yeah, and so like here's like Windermere, for example. So yeah, this is Dash that's kind of enabling us to do this. Oh yeah, we have like Belle Isle, where like there used to be that like kind of racist Confederate flag chicken restaurant, but I think that like closed down a couple of years ago. I'm not gonna lie, I was like a little sad when it closed down, even though it's like bad that it existed, but I just like remember seeing it going to the airport. It's always wild to see. So yeah, Orange County, really, there's something for everybody. And maybe I'll just kind of close out by pointing out how like down here, like this area is like very democratic. Like down here, like this, you know, Biden probably got like 70% to Trump's 30%. You know, this is like, these were like good precincts for Biden, like in the 60s. But it would take like a minute for me to go back and like edit to show you this. But if we kind of remember, we go back to the shift, it's those areas that like shifted a lot toward Trump. Just kind of like interesting how like places can like be really blue, but they can like shift a lot over time. And I don't know. And one other thing before I kind of move on from this map is there's this like this, so over here, this, you might be wondering like, what the heck is this really big blue area over here? This precinct only had like 10 votes or something. It was like nobody. So this is kind of like one downside of showing Coroplots, because like land isn't people, but like the map is land. So that's like why that's really blue, because like 1 or 2 people changed their votes. Like that's literally all it was. But if we kind of zoom in to like this area, I don't know how to like, oh, here we go. Well, I don't know how to like make it actually move, but this area right here is like shifted a lot toward Biden. if we look at what that is, it is a slightly red precinct. And it is where it's where the Orlando Country Club is. So like this is part of the trend of like educated, you know, elite people basically. Elites are Democrats now. It's kind of the, it's like that's like a oversimplification, but it's part of a broader trend. So yeah, lots of things that we can do with Plotly. I'm trying to think if there's anything else that I wanted to go over with the maps. I think that's probably all I'll go over. I think from here, it might be good to kind of point out that like, so there are like other people who have like looked at data in other places there. So this, for example, is there's this one really great political analyst, J. Miles Coleman, who writes for this great political publication called Larry Sabato's Crystal Ball. Larry Sabato is a professor at the University of Virginia in political science, has this website where he's been blogging about politics back like before blogging was like a thing, like early 2000s. And J. Miles Coleman is a collaborator of his, and like this is Houston, Texas, where we can see how a similar kind of shift has happened, where, you know, in certain overall Harris County, which contains Houston, shifted toward Biden, but the internal shifts were very different. And I should note that Orange County as well was basically unchanged at the county level, but as we could see, there were a lot of internal shifts, these like internal coalitional shifts that are happening in urban areas. And I think, as he has pointed out, the places that shifted toward Trump in the Houston suburbs were more predominantly Hispanic, and vice versa. White areas trended toward Biden, used to be more traditionally Republican. And that is very similar in Orlando. It's also what happened in Miami. And, you know, people talk about, there are even precincts in Boston that are plurality, like Cabo Verdean, that like moved toward Trump, or like Haitian precincts have like moved toward Trump. Very interesting shifts. And on the other side, the closer you are to a Whole Foods, the more what goes toward Biden. So these are trends happening. It's not just Orange County. It's really happening in a lot of places. But that brings me to another kind of statistical inference problem. So one thing that we're looking at here is precinct results. We're not actually looking at individuals. And one thing that there's been a lot of discussion about on Twitter amongst like analysts and political scientists is that just because we see shifts happening at the precinct level that are correlated with demographics, it's dangerous potentially to infer that those are changes happening at the individual level. And this is a problem in statistical inference called the ecological fallacy. And what the name is a little weird, like ecological, like why is it called ecological? It has to do with like aggregate geospatial data. A lot of data in social science and in ecology and economics, political science, social science is geospatial data, like the census, like elections, unemployment, etc. And a lot of times it's actually, usually it's true when we see like at an aggregate level, we can kind of extrapolate down to an individual level, like, oh, like Hispanic counties trending red, or like white affluent counties like trending toward Biden or something like that. It's a little dangerous to kind of take that down to the individual and say like, oh, like it's to kind of equate like a Democratic or like a white affluent county with a white affluent voter. And like one example where that can break down is in the 1968 presidential election, George Wallace, who was a open segregationist, kind of running a third-party campaign in 1968, where there was Hubert Horatio Humphrey for the Democrats and Richard Nixon for the Republicans. George Wallace, you know, openly racist guy, he actually did pretty well, disproportionately well, in majority Black counties. But it was not because like Black voters were voting for George Wallace. The reason was that white people who lived in places where there were more Black people were more supportive of George Wallace. So in this example, you know, we see that like, you know, quote unquote Hispanic precincts or white affluent precincts are making some sort of shift. But that isn't necessarily because individuals of those characteristics are driving that change. It could be that, you know, maybe in these more predominantly Hispanic precincts, the white people who live there are going more toward Trump. Or maybe, you know, in the whiter, more affluent places, the minorities who live there are becoming more supportive of Biden. And maybe the white voters aren't really changing that much. Unfortunately, without individual level data, it's like, it's not possible to know. We can have pre-existing priors that we might kind of say, well, the data confirms our hypothesis, but it doesn't falsify other hypotheses. So that's just kind of, again, in future work, if I bring in demographic data, it'd be really interesting to look at this. Also in Osceola County, which is very diverse. Yeah, this like whenever, I just kind of wanted to close on that. Like if you ever hear in the news, like, oh, like, you know, white areas or like Hispanic areas or something like that, like, again, it's kind of like with like land not being people. Just because a precinct votes a certain way doesn't mean that the people in that are all kind of following the exact same clean trend. So anyway, yeah, I'll just kind of close out and just kind of see if people have any kind of thoughts or questions on that.
I mean, I just said, I mean, I did like the presentation. I'm new to Python, so I'm just a beginner. So, but I mean, at least I grabbed what I wanted. We should start learning more how others are using Python. So
great, yeah. I'm also gonna try to like, I don't have this on GitHub yet, or in kind of like a blog post sort of, but if I get something together and published up there, I'll let Michael know so he can post it or something.
I'm glad that Mapbox works so well. When I went to Mapbox's site a little while back with a thought of maybe using it, I was so put off by the site itself and the flowing banners and the highly commercialized aspect of their website that I thought, well, this is maybe not what I want for a project, you know, a small scale open source project. But clearly, that was a misapprehension on my part.
Yeah, they definitely have a lot of corporate users, so it makes sense that their pricing structure, just as an example, it's based on the number of users with theoretically an unlimited number of calls, but it's definitely geared towards large enterprises with bulk discounts and mobile apps that have tons of users and so on and so forth. But you know, definitely just looking at this, once you get the exact style of map you want, you can just put it out there. And it looked really good. William, when I was looking at the different types of maps, the first image that you showed, it was what struck me the most compared to some of the other ones that were shown was, at least in the initial ones, just with the raw geospatial data, the precinct shape files, it was filling in, it was shading the entire shapefile in there from what we saw in the Jupyter notebook. But in the initial images that you showed, it was actually only filling in the land area, and the Windermere specifically stood out a lot, because I was kind of impressed that I was able to, okay, that's very clearly Windermere because I can see exactly where the lakes are, and that they're not shaded.
Okay, so yeah, great point. So the reason why, so if we kind of compare, how about I just kind of bring up that comparison? Because I can actually show you the implementation, like the one-liner for kind of like why that's the case. And I think it's actually, it's important enough that I could have kind of gone over it for a minute. Basically what's going on there is that, so with Mapbox, in these styles that they have all these different layers, like dozens of them. So if like we look at this here, if we go on to this thing called the layers tab, there's like 118 layers, where like if we zoom into, I don't know, like if what's like a major one, there's like roads. I can hide certain roads. You can like do stuff with, maybe this will work, but you kind of get the idea. I'm not, it's not like of course the demo effect is haunting me. They're like, you can like toggle what sort of layers you want to show. And then also you can like decide like where in that layer structure do you want your data to overlap with other stuff. So what that was is like, if I have that here, let's see if this works. So like here, I already have something showing here, where like Windermere is kind of, it has like the water around it. And I think you're saying like where like Windermere, you could like see like the whole blob, right? Is that what you mean, Michael?
Yeah, absolutely.
So like with this, like I have the water there. I could also here just like leave that out. So like what I've done, like I'm having like my data be below the water so that the water kind of overlaps it. But if I leave that out, then I can, it seems like maybe this notebook is just like really slow right now. It's just like taking forever to compute. Yeah, it's just taking really long. I don't know what's going on with my Jupyter notebook, but that's what it is. So this is like another one of the, okay, here we go. Of course, now it's working. That's like one of the things you can kind of tune, where like now, here we go. You can like, is this what you mean? Like where everything's kind of more filled in?
Yeah.
Yeah. Okay.
You're getting the precinct size, but for an area like Windermere specifically, like they call it the land of lakes, and it's very clear to see that like just how much land area there actually is when only the land in the precinct is shown.
Oh, cool. Yeah. Yeah. If I have, if I'm able to have this be zoomed to fit, yeah, like down here, there's, it seems like most of the Windermere precinct is water. And it seems like if I have this be, if I had this be underwater as well, this was another reason why I wanted to have a custom map where it has, where water is white, because when I have the water here, things like Windermere look a little weird. And down here in kind of like Southeast Orlando, where there's kind of a lot of lakes. So yeah, all these different things to change.
We have a question from the chat, and I believe this is the interpretation of the question here. But what is the average time that it takes for the data to be read and then visualized? I think what they're trying to get at here is how long, if you already have the code in place, how long does it take to, if you were to do a kernel reset and run in this Jupyter notebook, about how long would it take to output? And my guess is that this is in such a way, if you wanted to put this into a data visualization pipeline or other, some other kind of process, what would be the response times for reading in the information and outputting a project on, say, a web server?
Yeah, good question. So with everything kind of already being ready to go right now, it would take maybe 20 seconds to kind of read in that huge PDF file and like parse all the data from it. And then I think maybe just like 30 seconds to kind of load everything up, merge everything together, create the columns, load in Plotly, and make the 3 or 4 or 5 visualizations that you want. Maybe a minute to create all of them. If you're not, and if you're on a Zoom call, maybe it takes like 4 minutes because the CPU time of like rendering stuff and showing the pixels is a little longer.
So definitely CPU bound for this.
Yeah, exactly. Yeah. And the developer time, I think I probably spent, in case they're curious, I probably spent like all of a Saturday afternoon and evening, and then a Sunday afternoon, and I kind of got to something like this. And then I spent like another day or two figuring out how to edit Mapbox styles. Just figuring out, like, of course, like half of the time was spent to like the last 10% of like the visually impactful work. But like just the like figuring out the Mapbox styles and like the relative positioning of things and stuff like that took like a day or two, but yeah.
Oh, and as we saw last month with Ricardo's talk, the responsiveness of pandas data frames and Geopandas, it definitely matters how you are processing the data.
What happened there? What was the situation?
So with Ricardo, who's is on the call here, was showing off a handful of methods that you could use to bin data, and
oh yeah,
the subtext of it was the more you allow the built-in features of pandas and pandas data frames, the more compiled C code is able to process your data, and you're able to dramatically reduce the runtime for even a reasonably middle data set of a couple million rows.
As opposed to like a Lambda function or something?
Yeah, absolutely. I think the
correct.
Yeah, like the first one it took 15 seconds to do a couple million.
Yeah, the first one was a traditional. The first one was a traditional for loop, and then there was the function cut. Okay, that was really the win. Yeah, but usually if you go NumPy, if you can translate that code to NumPy, you get pretty decent performance times. Yeah.
Yeah, just so for Wes, our new Pandas convert with like Lambda function and NumPy and stuff like that. These are like different ways of doing math. And like NumPy, it's like there's some like really fancy math stuff that uses these like low level fancy programming languages like Fortran and C and stuff like that can do like really efficient CPU stuff. And then what I'm using here is Python, which is a higher level programming language, still pretty fast, but where the way that the actual CPU on the computer kind of takes the instructions and does stuff is not as efficient as it could be because of how it's reading in data and following instructions. That's all. Yeah. Anything else? Let's see. Oh yeah, here we go to see the map. Carlos, great, yeah. What sort of other like thoughts do people have about like what you're curious about seeing? So like Gerald, I think, mentioned demographic data. I mentioned maybe pulling in something like Osceola County. I've also thought about maybe like looking to see if I could find like more historical elections, like going back to the 90s or 80s and something, and kind of seeing how vote patterns have shifted, but I'm not sure where that data is. I wonder just like what people were curious about. And thanks for
William. William, also you could do an animation, next time.
Oh,
right?
Yeah.
In that line of thought, that you could do, a certain series from, let's say, from the 80s to 2020, and then do an animation. That would be cool.
That would be sweet.
Yeah.
Yeah.
I don't think this will appear for you in the chat since you had to exit and rejoin, William. But Ricardo also posted a link to historical census data from PyPI that could be pulled into.
Yeah, I missed that.
Census data. Yeah.
Yep. I'll repost it in the chat for you here.
Yep.
Oh yeah, census data. I've seen their GitHub thing. It's like this is a website, right, for like journalists and stuff. It's like used by journalists, I think.
Well, I just Google it.
Oh, okay, cool, yeah.
I just Google Python, census data, library, and this is what it, it was the first one, the first search.
Sweet.
I have done some, a reading of ACS data, but not from Python, from R. And I guess what you need is an API, it's a token, an API. You have to request it, but they'll give it to you. Okay.
From census.gov.
Nothing out of the ordinary. And I don't know if this is the same, but probably will be the same process because it's coming from the same source.
Okay. Well, if I can deal with the Mapbox stuff, I think I can deal with the census.
Oh yeah, and you can use the tooltip in Plotly to then add that information that will be it will give you more insight in terms of population, income, ethnicity, groups, etc. Yeah,
that would be great.
That'll be awesome.
Thanks for the suggestion. And
sure.
Yeah.
Taking a cue from Jerry.
Yeah, I'm also thinking with like next steps, like there are like a few different things I could work on to improve this, because I mean it's just a bunch of stuff in like disorganized Jupyter notebooks, so really like anything would be an improvement. But like using a Postgres has this really nice, maybe you're familiar with this, the PostGIS extension, which has like a bunch of nice like geospatial features, has like nice like column data types for these shapes, where basically like pandas is to Postgres as like Geopandas would be to like PostGIS, where PostGIS can like do all sorts of nice like structured data querying and storage of this geospatial data. So I was thinking about like making some sort of pipeline, and then like if I have demographic data there, PostGIS has nice ways to combine geospatial data that corresponds to different geometries or like different kind of subdivisions. So I was thinking of doing that, but I don't know if it would be like too much work, like not worth it. But if anyone's kind of worked with that, I don't know, let me know. It'd be fun to kind of talk about
it. Excellent job, William. Really, really appreciate it. Excellent.
Thanks. I appreciate it. Appreciate it as well.
Absolutely. And I'm sure we'd love to see you back for a follow-up talk when you get some of those other projects in there.
I'd love to.